Good morning students. So today we're going to solve question 15 of GATE CSE 2024 set 1. The question states that which statement is false. Of the given statements, which one statement is false, right? So the first statement states that in the cycle stealing mode of a DMA, one word of data is transferred between IO devices and the main memory in a stolen cycle. So first of all, what does a DMA means? DMA stands for direct memory access controller basically. So it's a controller that is present in the CPU that enables that automates the task of shifting data, because if shifting data is performed in a program manner, I mean, let me make a CPU here, right? And this is a device, some device, and this is your memory meaning RAM, right? So a particular byte can be taken from this byte, or even a bit can be taken from this, and then this byte could be written here. This is one byte at a time. So this is a programmed way of doing it. But DMA automates this task. DMA is here present, and it will the CPU gives its instruction to take this amount of data from here and shifts it to this particular location memory. It will automatically do it. The CPU would be free to do other tasks. That is the purpose of a DMA. Now cycle stealing mode, what does cycle stealing mode means? So suppose that the memory has ports, right, and that those ports are used for accessing the memory, right? So this is a bus is connected to that. So a bus while the bus is being used by a CPU, a cycle would be and every clock cycle the CPU writes or reads, right? So suppose some stolen cycles are taken. I mean, while the CPU is doing, some cycles are given to the DMA for it to perform a task, and then the CPU does its task and the DMA will continue the same task, right? Suppose this is the amount of memory that has to be copied from a device to the RAM at this location, right? So it is going to be copied from here to here in one cycle, and then the CPU does some task here, then another cycle this amount of memory would be copied here, right, and so on and so forth. The whole memory would be copied from this device to your RAM. So this thing is known as stolen cycle method, by which DMA can transfer data from IO device to main memory. So this is what the first statement said, and this is a true statement. This is how a DMA actually operates. This is how stolen cycle, there is a concept of stolen cycle, and that is what they are stating: transfers between IO device and memory in a stolen cycle way. So this is a true statement, but we have to find a false statement. So this cannot be the answer. Now come to B. For bulk data transfer, the burst mode of DMA has a higher throughput than cycle stealing mode, right? So suppose that what does a burst mode mean, right? This bulk data transfer burst mode of DMA. So what does a burst mode of DMA means? For it is upon the CPU whether it allows for cycle stealing mode by which DMA operates, or it can give the whole memory access to the DMA only, and the DMA can directly just start copying and would only relinquish the control of the bus once the whole data has been copied. That would be known as burst mode of DMA access, right? So obviously if burst mode is being done, it would be faster, because there is no CPU taking back a control and then working on that. Hence burst mode would have higher throughput, means it would do the task faster, right? So that is what this statement is saying: the burst mode of the DMA has higher throughput than cycle stealing mode. Yeah, this statement is also true, but we are trying to find a false statement, so this is not an answer. Now C states that programmed IO mechanism has a better CPU utilization than the interrupt driven IO mechanism, right? So programmed IO basically means that there is an IO device, right, and that device needs to basically, suppose for example that you press a key on the keyboard, right? So how would the CPU know that the key has been pressed? There are two methods of doing this. First is that CPU periodically checks the buffer of the keyboard, and in the buffer there would be a key press stored. If there is a key press stored there, then the CPU would know, yes, okay, now I know that this thing is pressed, now I can take action on this. But because the CPU is programmatically going and then checking, it is known as programmed IO mechanism. On the other hand, if if the device interrupts the CPU, like basically issues an interrupt, that method would not be programmed IO. That's an interrupt driven mechanism, right? Obviously, it is obvious to us that if the CPU always goes and checks, it would be a lot of wasted CPU cycles, right? So what the statement is saying, that the CPU programmed IO mechanism has a better CPU utilization than the interrupt driven mechanism. So it does keep, programmed IO does keep the CPU busy more, but it does not utilize the CPU. It wastes the CPU cycles as far we are concerned, compared to interrupt driven mechanism. So this statement, if interpreted that way, would be false, right? So let's keep it aside and then go to fourth statement. If fourth statement is also false, then C is answer directly, but C does seem to have some falsehood to it. So let's keep that in mind and let's go to D option. The CPU can start executing an interrupt service routine faster with vectored interrupts than with non-vectored interrupts. Okay, so now it is telling about interrupt service routine only. So what does it mean to, let's take it this way. This is a device and this device issues an interrupt, right? And the CPU gets, how much information would this interrupt give the CPU? That is what is the difference between a vectored interrupt and non-vectored interrupt. If in a vectored interrupt, the interrupt gives the information, suppose this device has a number 4, it will give the information for some 47 or 50 something, and that number would then be used in a vector. There is a vector of interrupt information, so that number can directly be used in 47, and then from 47 the routine, the code for handling that interrupt would directly be invoked. This is vectored invocation. Now non-vectored invocation would be that this thing just gives that I have some issue. Now then the CPU would just go and check back to it and then get the information regarding what the issue is, and then accordingly would decide and then would issue the routine, not through the table but directly. So obviously non-vectored takes more steps for the CPU, while vectored is quite straightforward. So obviously your vectored interrupts are faster. So, and they are setting that only. The CPU can start executing an interrupt service routine faster with vectored interrupts than with non-vectored interrupts. So this is a true statement. This is actually a true statement. Because it's a true statement, it cannot be the answer. C, on the other hand, is a false statement. So we are trying to find a false statement. So C is the answer. Hope you like the video. Thanks for watching.